Welcome to Concepts in Chemistry. In this talk, we'll discuss how Millikan determined the charge of an electron and how this charge was used to calculate the mass of an electron. To start, let's review Millikan's oil drop experiment setup. In this picture, it's a drum. The drum consists of two compartments. These compartments are separated by two plates, and these plates are shown in red. The top plate is positively charged, while the bottom plate is negatively charged. The top plate has a hole in it, while the bottom plate has no hole. Also, there is a viewing camera. Through the camera, Millikan follows droplet and controls its motion by adjusting the electric field between the plates. Also, there is an X-ray source. These X-rays strike and remove electrons from surrounding air molecules. These electrons then stick to the oil droplet. Also, there is a spray bottle. This spray bottle is used to spray tiny oil droplets into the top compartment. These oil droplets then fall slowly through the hole in the top plate. As they fall through the hole, Millikan follows droplet and controls its motion by adjusting the electric field between the plates. As the droplet falls through the hole, Millikan adjusted the voltage between the plates until such a point that the droplet became suspended between the two plates. At this point, the gravitational pull on the droplet was equal to the electrostatic pull. With this information, Millikan was able to calculate the charge of an electron to be minus 1.6 times 10 to the power minus 19 coulombs. He also observed that regardless of the number of electrons acquired by the droplet, the value of the charge was always a multiple of minus 1.6 times 10 to the power minus 19 coulombs. So how was the mass of an electron calculated? To calculate the mass of an electron, scientists had to bring in the mass to charge ratio of an electron. And the mass to charge ratio of an electron was determined by J.J. Thomson. So once you bring the mass to charge ratio, you can then multiply the mass to charge ratio by the charge of an electron. Okay. And once you do that, you then be able to calculate the mass of an electron. So here, we do have mass to charge ratio equal to 5.60 times 10 to the power minus 9 grams per coulombs. Then you multiply each side of the equal sign by E. So you are trying to isolate M. So these E's will cross out. And you now have M equal to 5.60 times 10 to the power minus 9 grams per coulombs times the charge. And we already know Millikan determined the charge of an electron to be 1.60 times 10 to the power minus 19 coulombs. So you substitute this value for E. And once you do that and solve for M, you get a value of 8.96 times 10 to the power minus 28 grams. As a result of improved measurements today, we now know that the mass of an electron is about 9.11 times 10 to the power minus 28 grams, which is quite close to what was determined earlier. To make it easy for us, the charge on an electron is normally written in a short way as 1 minus. So charges of other subatomic particles are then reported in multiples of the electron's charge, which is of course is 1 minus.